All right, good morning. Welcome back to days 3 through 5, looking at graphs of rational functions. We will be using our calculators, so make sure you have those handy. So a few things we learned yesterday was some things about our zeros. So if you look at your zeros of your numerator, remember what that tells us, as well as our zeros of our denominator. So off to the side, what we can start by doing is setting those equal to 0. And then let's talk about what happens when we solve those and what that gives us. So here we get plus or minus 1. Those are the zeros of our denominator. Over here we're going to factor. So take a minute and factor that. Okay, so once we factor the numerator and the denominator, that's going to tell us a little bit more about our graph. Remember, our zeros of our numerator give us our roots, and so that is 1/2 and -4. So what does that mean when it comes to our graph? It means that's where it's crossing our x-axis. So at -4, you're going to have a 0. At 1/2, you're going to have a 0. Y-intercept, plug in 0 for all your x's, and you get -4 over -1, which is a positive 4.
For my students? No,
And then as we learned yesterday, our zeros of our denominator is going to give us our vertical asymptotes. And so that's what makes your break in your domain. So when you're trying to fill in domain of rational functions, you need to look at what makes your denominator 0. So our domain will be starting from -infinity to -1, union -1 to 1, and then union 1 to positive infinity. So we can fill out all of that stuff without even looking at our graph. And then it says use calculator to sketch your graph below. So what your graph actually looks like is, I'll do it in green here, goes up and approaches your asymptote there. This is up here, and this one is right there, okay? What you guys haven't learned about yet is there is what's called a horizontal asymptote, and we will talk about that after spring break. And that's this line that's going to be going through here that your graph is approaching. So actually that green graph is not crossing it there. It is approaching it, but it's not crossing it. So you guys don't see it on your calculator. And again, we haven't talked about it yet. So that's what our graph looks like, okay? So it says end behavior. Where are ends approaching? It's approaching +2, and the way we know that is if you were to scroll out on your calculator, you're going to see your y values get closer and closer to 2 from underneath, and over here you're going to see it get closer and closer to 2 from above. So as x approaches -infinity, our function, which we called r of x, is approaching 2, and as x approaches positive infinity, r of x will also approach 2. Describe the graph when the denominator is 0. Those are your vertical asymptotes. Describe the intervals of increasing and decreasing. So it actually looks like this the whole time this function is decreasing. So it actually is going to be decreasing over the domain. So it's decreasing from -infinity to -1, from -1 to 1, and from 1 to infinity. Never increasing. Okay, so notice the whole time from left to right it's going down. And then where does the graph change signs? The only place that it changes signs are at your x-intercepts today. So at x-intercepts. So what I want you to do is I want you to go ahead and try question 2. I'm going to pause the video and then you will check back in to see if you have the same answers filled in your table. Okay, so here is what your boxes should look like. So starting with domain, remember your restrictions on your domain come from where your denominator is 0 because we can't divide by 0. So if you plugged in an output at 2 or -2 or looked at your table of values at 2 or -2, it would tell you that it's undefined. And that's because we can't divide by 0. So that's where our domain comes from. That's where these vertical asymptotes come from. Next up are your real zeros. That comes from setting your numerator equal to 0. And that's where you get negative 4, 0. So that's this point right here. That's your x-intercept, and that's your only x-intercept. Your y-intercept comes from plugging in zeros in for x. There's your graph. End behavior, you can see that as x gets really small, it's going to approach 0, but from underneath. So if you're looking out here at the end where I'm highlighting in green, it's going to be getting closer to 0, but in negative from underneath the graph. So all the y values will be negative, whereas x gets really big, it's going to get closer to 0 as we come from the positive direction. It says describe the graph when the denominator equals 0. Those are your vertical asymptotes. Describe the intervals of increasing, decreasing. Now this is going to be a little bit trickier because you actually have a relative min right here. And you have a relative max right here. Okay, which happens at negative 0.54 comma something. It doesn't really matter because we don't need that. So when you're looking at your intervals of increasing, it's increasing, I'll get the highlighter, starting here at that minimum until it reaches your asymptote. Then it's going to increase here until it reaches that relative max of negative 5.4. And that's the only place it's increasing. Decreasing, it's decreasing from negative infinity until it reaches that relative min. Then it decreases here, and then decreases all the way through there. So this one, you just have to go through and find those relative mins and maxes, and maybe you didn't even notice that, and that's okay, because again, we're just in the learning process of this.